Welcome to Sleepy Earth Channel. Tonight, we're traveling back to a prehistoric world where giant crocodiles, larger than buses, may have ruled the rivers alongside dinosaurs. Could these ancient predators really drag dinosaurs beneath the water? Or has history exaggerated their power over millions of years? In this journey, we'll explore deadly swamps, fossil mysteries, and the terrifying hunters hidden beneath ancient rivers. Before we begin, leave a comment telling me what city you're watching from tonight. And let's drift back into the lost world of prehistoric Earth together. More than 90 million years ago, long before humans would ever imagine monsters hiding beneath dark water, enormous rivers cut across parts of the Earth that no longer exist in the same form today. Northern Africa was not the endless Sahara Desert people know now. Much of it was green, humid, flooded, and alive with slow-moving waterways so wide they looked almost like inland seas. Dense forests leaned over muddy banks. Giant ferns and conifers stretched into thick, warm air heavy with insects. Storms rolled across the horizon with almost no interruption during certain seasons, feeding endless wetlands where visibility disappeared beneath mist and humidity. And somewhere inside those rivers, barely visible beneath floating vegetation and brown water, something massive waited without moving. The terrifying part is that in many cases, nothing in that world needed to chase very far to dominate it. The environment itself did most of the work. The late Cretaceous period created conditions unlike almost anything on modern Earth. Global temperatures were significantly warmer. Polar ice was either extremely limited or completely absent for long stretches of geological time. Sea levels rose so high that shallow inland oceans split continents apart. North America itself was divided by a massive body of water called the Western Interior Seaway, turning entire regions into humid coastal ecosystems filled with swamps, river deltas, and marshlands. These places became ideal territory for large, semi-aquatic predators because water changes the rules of size. A creature that might struggle under its own weight on land can become terrifyingly efficient in rivers and swamps where buoyancy supports enormous mass. That may be one reason prehistoric crocodilians reached sizes that still sound almost fictional today. Some scientists believe certain species approached lengths over 30 feet, and perhaps even more, depending on fragmentary fossil estimates. But what mattered was not simply their length. It was the combination of patience, armor, stealth, and explosive force. Dinosaurs often dominate the imagination when people think about prehistory because they moved openly across landscapes. They were visible, loud, towering. But rivers hide things. Water conceals scale better than forests ever could. Even today, a 15-foot crocodile can remain almost invisible until the final second before an attack. Now imagine something much larger existing in ecosystems where nearly every animal eventually had to approach the shoreline. That detail may explain why ancient swamp systems became some of the most dangerous environments on Earth. Many prehistoric rivers functioned less like safe water sources and more like giant feeding traps. Herds of dinosaurs still needed to drink. Smaller predators still needed to cross waterways. Massive fish gathered in deep channels. Dead animals floated downstream during floods and drought cycles. In ecosystems like these, an enormous crocodilian did not need to behave like a sprinting hunter. It only needed to wait longer than everything else around it. Fossil evidence suggests that some of these ancient crocodilians were not simply oversized versions of modern alligators. Their bodies evolved in strange directions depending on the ecosystem they occupied. Some had long, narrow snouts, likely adapted for catching fish. Others developed broader skulls, capable of generating crushing bite forces, powerful enough to damage bone. One of the most fascinating parts of prehistoric crocodilian evolution is that they occupied multiple ecological roles at once. Certain species may have behaved partly like giant river predators, partly like scavengers, and partly like opportunistic ambush hunters, capable of attacking almost anything vulnerable enough to approach the water. That flexibility might have been one of their greatest evolutionary advantages. Dinosaurs often specialized heavily for particular lifestyles. Some were built for speed, others for immense bulk, others for hunting specific prey. But crocodilians survived by conserving energy and exploiting moments of weakness. In many ways, they represented the opposite philosophy of survival. Instead of dominating through constant movement, they dominated through efficiency. Even their anatomy reflects this strategy. Crocodilian bodies are astonishingly optimized for ambush predation. Eyes and nostrils positioned high on the skull allow them to remain nearly submerged while still watching the environment. Thick, armored skin provides protection during violent struggles. Their tails generate explosive bursts of power in water despite long periods of stillness. Modern crocodiles already demonstrate this system with disturbing effectiveness, and prehistoric forms may have amplified it to a scale difficult to visualize. Imagine approaching a riverbank where the mud itself appears to breathe. One reason these environments became evolutionary hotspots for giant crocodilians may involve the sheer abundance of food moving through ancient waterways. The Cretaceous world supported immense biodiversity. Fish species grew enormous. Turtles reached sizes comparable to small vehicles. Seasonal migrations likely concentrated prey near rivers during drought periods. Flood cycles carried carcasses downstream for miles. A massive crocodilian capable of eating fish, scavenging dead animals, and occasionally ambushing dinosaurs would have occupied one of the most stable positions in the food chain. Some paleontologists have even suggested that large crocodilians may have influenced dinosaur behavior around waterways in ways impossible to fully reconstruct now. It is difficult to know how often dinosaurs avoided certain river crossings, or whether they recognized particular stretches of shoreline as dangerous territory. But modern herbivores absolutely learn to fear crocodile-infested water. Zebras hesitate at rivers. Wildebeest bunch together before crossing. Even large animals behave differently near hidden aquatic predators because the threat feels unpredictable. That same psychological pressure may have existed in prehistoric ecosystems on a far larger scale. One unsettling possibility is that some dinosaurs may have spent much of their lives surrounded by predators they could rarely see clearly. The ancient rivers themselves were likely chaotic places. Sediment-heavy currents reduced visibility underwater. Fallen trees formed submerged barriers. Insects swarmed above stagnant pools. During hot seasons, shrinking waterways may have trapped huge concentrations of fish and animals together, creating feeding frenzies for predators. During flood seasons, entire landscapes disappeared beneath muddy water. This instability favored creatures capable of surviving long periods without food, while remaining highly dangerous when opportunities appeared. Crocodilians excel at exactly that strategy, even today. Some can survive months between large meals. That ability becomes incredibly important in ecosystems where prey availability fluctuates violently with climate and season. It also means giant prehistoric crocodilians did not necessarily need constant, successful hunts to maintain dominance. A single large kill could sustain them for extended periods. Another reason these ancient swamp worlds feel so alien is that oxygen levels, temperatures, and plant distributions created ecosystems operating under very different biological pressures than modern Earth. Some prehistoric animals grew rapidly because warm climates allowed longer active seasons. Others reached enormous sizes because wetland environments provided abundant food and reduced the physical limitations imposed by gravity. The result was a world where giant predators evolved repeatedly across multiple branches of life. Not just dinosaurs, but fish, reptiles, amphibians, and marine hunters all expanded into massive forms. In that environment, gigantic crocodilians were not evolutionary accidents. They were products of a planet unusually favorable to oversized ambush predators. Yet despite their terrifying image, there is still major scientific debate about how aggressive some of these creatures truly were toward dinosaurs. Size alone does not automatically mean active predation on giant prey. Modern crocodiles are opportunists. They prefer vulnerable targets whenever possible because injury is dangerous for ambush predators. A broken jaw or damaged limb can become fatal in the wild. That logic may have applied to ancient crocodilians too. Even a massive river predator may have preferred juvenile dinosaurs, sick individuals, scavenging opportunities, or isolated prey near water, rather than direct confrontations with healthy adults. But the uncertainty itself is what makes these creatures so fascinating. Fossils provide fragments, not full scenes. A bite mark on bone can suggest attack, scavenging, territorial conflict, or something harder to interpret. Scientists reconstruct possibilities from incomplete evidence buried for tens of millions of years. Sometimes entire theories shift because of a single newly discovered skull fragment or tooth pattern. In a strange way, prehistoric rivers remain mysterious partly because water destroys evidence so efficiently. Floods scatter remains, currents separate skeletons, mud buries tracks quickly. The most violent moments in these ecosystems often vanished almost instantly after they happened. And yet enough evidence survived to reveal something extraordinary. There truly were crocodilian predators large enough to compete with some of the most famous dinosaurs on Earth. Some may have outweighed certain theropods. Others possessed bite forces potentially rivaling the strongest known land predators. And unlike dinosaurs built primarily for movement across land, these animals controlled territory where gravity itself became less important. Water transformed them into living traps hidden beneath calm surfaces. That idea changes how the prehistoric world feels. Instead of imagining dinosaurs safely towering over every other creature, you begin to see an ecosystem divided into zones of control. Open plains belonged to some hunters, dense forests to others. But rivers and swamps followed older laws. At the shoreline, size alone may not have guaranteed safety. And perhaps the most unsettling detail is how little that rule has truly changed. Even now, millions of years later, some of the deadliest predators on Earth still hunt by remaining almost completely motionless beneath the water, waiting for thirst to overcome caution. Long before the Sahara became a silent ocean of sand, it may have been one of the most dangerous river systems on Earth. The modern desert gives almost no hint of what existed there during the middle of the Cretaceous period, roughly 110 million years ago. Today, the region feels empty beyond survival. But buried beneath dunes stretching across northern Africa are fossils from a world overflowing with life. Giant fish moved through deep brown rivers. Primitive lungfish hid in muddy shallows, waiting for droughts to end. Massive dinosaurs crossed humid floodplains covered in dense vegetation. And somewhere beneath the surface of those rivers lived a predator so large that even experienced paleontologists struggled to fully understand what they were looking at when the first major remains were uncovered. Its name would eventually become Sarcosuchus, often translated as flesh crocodile, though the nickname that stayed with the public was much simpler and somehow more unsettling: Super Croc. The name sounds exaggerated at first, almost like something invented for television rather than science, until you begin looking at the actual scale of the animal. Some estimates suggest Sarcosuchus may have reached lengths between 35 and 40 feet, possibly weighing several tons. Its skull alone stretched over 5 feet long in some fossil reconstructions, large enough that a human standing beside it would appear strangely small. But the size is only part of what makes the animal so fascinating. The real mystery begins when scientists try to determine what kind of predator Sarcosuchus actually was. Because, despite its terrifying appearance, its anatomy tells a more complicated story than many people expect. The first thing researchers noticed was the shape of its snout. Unlike the broader, crushing jaws of some later giant crocodilians, Sarcosuchus had a relatively elongated snout lined with over 100 teeth. In modern crocodilians, long, narrow snouts are often associated with fish specialists. Animals like the gharial of India evolved similar shapes because thin jaws move through water with less resistance, allowing rapid sideways strikes against slippery prey. That detail has led some scientists to believe Sarcosuchus may have spent much of its life hunting giant fish rather than actively ambushing enormous dinosaurs. But then, another problem appears. Sarcosuchus was not merely a fish hunter, scaled up slightly larger than modern crocodiles. It was operating in ecosystems where even the fish were monstrous. Some ancient river species exceeded the size of modern sharks. Others carried armor-like scales thick enough to resist weaker predators. And Sarcosuchus itself possessed a body built less like a delicate specialist and more like an armored tank, partially submerged in mud and water. Its back was covered in thick osteoderms, bony plates embedded in the skin that acted almost like natural armor. Its tail generated immense power in water. And perhaps most importantly, it lived in an ecosystem where nearly every large animal eventually approached the shoreline. That changes the entire interpretation of the creature. Even if Sarcosuchus evolved primarily to exploit fish-rich rivers, opportunistic behavior may have expanded its diet far beyond aquatic prey. Modern crocodilians already demonstrate this flexibility constantly. A Nile crocodile might spend days feeding on fish and birds, then suddenly attack a zebra crossing a river. Large crocodilians are less defined by loyalty to one prey type and more by opportunity. If something vulnerable enters striking range, the rules change immediately. That possibility becomes much more dramatic in prehistoric ecosystems where many dinosaurs shared waterways with giant crocodilians on a daily basis. One of the most intriguing aspects of Sarcosuchus is that it lived in the same general environment as Spinosaurus, the enormous sail-backed predator that may have spent much of its own life hunting aquatic prey. This creates one of the strangest predator ecosystems in prehistory, because both animals appear partially adapted for life around rivers. Some scientists have wondered whether they competed directly for food. Others suspect they occupied slightly different ecological roles that reduced constant conflict. Spinosaurus may have hunted actively through shallow water, while Sarcosuchus relied more heavily on ambush and opportunism. But no one knows exactly how those interactions played out because the fossil record rarely preserves behavior clearly. What survives are fragments of moments, teeth, bones, bite marks, sediment, enough to suggest possibilities without fully resolving them. And perhaps that uncertainty is why Sarcosuchus feels so compelling compared to many prehistoric animals. It exists partly inside a scientific gray zone where imagination and evidence overlap without completely merging. The Sahara itself adds to the eerie atmosphere surrounding the creature. It is difficult to overstate how alien ancient North Africa would feel compared to the modern desert. Satellite scans and geological studies reveal traces of massive river systems hidden beneath present-day sand. Entire floodplains once stretched across regions now considered nearly lifeless. During wet periods, storms may have transformed the landscape into endless swamps and channels thick with vegetation. In some places, seasonal floods likely reshaped entire ecosystems repeatedly. This matters because unstable river systems often favor ambush predators. Floods bring dead animals. Droughts concentrate prey into shrinking pools. Mud traps weaken large herbivores. And visibility remains poor in sediment-heavy water. A predator does not need to dominate every fight in that environment. It only needs to wait for conditions to create vulnerability. Sarcosuchus may have mastered exactly that kind of patience. Some paleontologists believe the animal continued growing throughout much of its life, similar to certain modern reptiles. If true, the oldest individuals may have become almost unimaginably large compared to younger adults. That raises another unsettling possibility. Ancient rivers may not have contained one stable population of equally sized predators, but instead a hierarchy where giant older individuals controlled the best feeding territory, while smaller crocodilians survived along the edges. In modern crocodiles, territory disputes can become brutal, even among animals far smaller than Sarcosuchus. Scaling that behavior into Cretaceous ecosystems creates an image of river systems ruled not by constant motion, but by dominance through intimidation and sheer mass. And unlike many large predators, crocodilians conserve energy extraordinarily well. A giant Sarcosuchus may have spent most of its life almost motionless. The terrifying power of the animal may have appeared only during sudden bursts lasting seconds. There is also something psychologically disturbing about the way crocodilians hunt compared to land predators. A charging theropod announces danger openly. You hear movement, you see the attack coming. But crocodilians erase visibility itself. The surface of the water becomes deceptive. Calm no longer means safety. That hidden danger may explain why giant crocodilians continue capturing human imagination even more than some dinosaurs. They trigger a deeper fear connected to uncertainty beneath the surface. Sarcosuchus amplifies that fear into prehistoric scale. Imagine standing beside a warm Cretaceous river at dusk. Insects hum above reeds taller than a person. Small fish disturb the water near the bank. Somewhere across the floodplain, a dinosaur herd moves slowly through fog and vegetation. Nothing appears immediately threatening, but beneath the muddy surface, nearby, rests an animal longer than a city bus, almost completely invisible except for its eyes and nostrils. And perhaps the strangest part is that it may not even be hunting at that exact moment. Large crocodilians often exist in a state of suspended violence, conserving energy until the environment presents the right opportunity. That efficiency may be one reason crocodilian body plans survived for such immense stretches of geological time. Evolution rarely preserves weakness for millions upon millions of years. Yet crocodilian designs endured mass extinctions, climate shifts, collapsing ecosystems, and changing continents. Sarcosuchus represents one of the most extreme versions of that formula ever discovered. Still, there remains major debate about how aggressive it truly was toward dinosaurs. Popular documentaries often portray it dragging giant dinosaurs into rivers regularly, but the evidence is more cautious than the cinematic versions imply. Some scientists argue that its snout shape strongly supports a fish-heavy diet. Others counter that an animal of such size almost certainly behaved opportunistically whenever possible. Both views may contain truth simultaneously. Large predators do not always fit neatly into one ecological category. A modern bear can eat berries, fish, carrion, and large mammals within the same season. Sarcosuchus may have operated similarly on an even larger scale. And perhaps that flexibility made it more dangerous, not less. A predator willing to exploit almost any food source becomes incredibly resilient. Toward the end of its reign, the world around Sarcosuchus continued changing. River systems shifted, climates fluctuated, new predator lineages evolved. Yet for millions of years, enormous crocodilians remained among the hidden rulers of these waterways, not because they were always the fastest or most intelligent hunters, but because they exploited one of the oldest truths in nature. Eventually, nearly every living creature must approach water. And in the ancient Sahara, that simple necessity may have turned entire rivers into silent killing grounds, where even dinosaurs could disappear without warning beneath the surface. Roughly 80 million years ago, North America was not the continuous landmass people recognize today. A massive inland sea split the continent almost in half, stretching from the Arctic Ocean down toward the Gulf of Mexico. Along its coastlines, enormous wetlands spread for hundreds of miles through warm subtropical climates where rivers emptied into shallow seas filled with predators. Dense forests leaned over black water channels. Storms rolled constantly across humid skies. Herds of duck-billed dinosaurs moved through muddy floodplains, while armored dinosaurs disappeared into fern-covered swamps. But in some parts of this world, the most dangerous predator was not walking openly across the land. It was hidden in the water, with only its eyes exposed above the surface. Its name was Deinosuchus, and unlike Sarcosuchus, which still leaves scientists debating whether it specialized more heavily on fish, Deinosuchus carried an entirely different kind of anatomy. Everything about its skull suggested violence designed for crushing power rather than speed through water. The name itself translates roughly to terrible crocodile, and for once, the dramatic label may actually undersell the animal. Some estimates place Deinosuchus at over 30 feet long, though exact measurements remain debated because no completely intact skeleton has ever been found. What scientists have recovered instead are scattered remains from across ancient North America. Enormous vertebrae, massive armored plates, fragments of jaws, and teeth thick enough to look almost carved from stone. But the skull fragments changed everything. They reveal the predator built less like a sleek aquatic hunter and more like a machine designed to generate catastrophic bite force. Modern crocodilians already possess some of the strongest bites ever measured among living animals. Saltwater crocodiles can crush bone with astonishing efficiency. But Deinosuchus operated on a scale beyond anything alive today. Its snout was broader and deeper than the long, narrow jaws of Sarcosuchus. Its teeth were thick, blunt, and incredibly robust, especially toward the rear of the mouth, where crushing pressure becomes most important. Some paleontologists believe Deinosuchus may have specialized in handling large, struggling prey rather than primarily catching fish. And perhaps the most disturbing evidence supporting that theory comes from dinosaur bones themselves. Several fossils discovered in North America contain bite marks matching Deinosuchus teeth. In some cases, the bones show clear signs of healing around the injuries. That detail changes the entire story. A healed bite mark means the dinosaur survived the initial attack long enough for bone tissue to begin repairing itself. Somewhere in the swamps and river systems of late Cretaceous North America, dinosaurs escaped encounters with giant crocodilians, carrying wounds large enough to scar their skeletons permanently. One hadrosaur fossil in particular became famous because of deep puncture marks believed to match Deinosuchus' teeth. The attack may not have killed the animal immediately, but it proved something critical. Deinosuchus was absolutely capable of attacking large dinosaurs directly. Whether those attacks were common or opportunistic remains uncertain, but the physical evidence exists, and that evidence forces a terrifying realization. The riverbanks of ancient North America were not safe even for animals weighing several tons. One reason Deinosuchus feels more frightening than many giant theropod dinosaurs is because of how little movement it likely required to kill. Large land predators burn tremendous energy. They must chase, overpower, and physically control prey, often capable of fighting back. But ambush predators use environment instead of endurance. A massive crocodilian waiting at the edge of a river only needs one moment where gravity, water, and panic work together. If a dinosaur slipped in mud or lost footing crossing a flooded channel, the fight could change instantly. Water removes balance. It slows reaction time. And perhaps most importantly, it amplifies the power of a creature already perfectly adapted to moving through it. Deinosuchus did not need to outrun a dinosaur across open terrain. It only needed to pull part of the dinosaur into an environment where the rules favored the predator completely. Modern crocodiles demonstrate this principle constantly. Large crocodilians often target vulnerable angles rather than launching suicidal attacks against healthy adults head-on. They wait near crossings. They ambush from concealment. They attack moments of weakness. Deinosuchus may have used the same strategy on a much larger scale. A fully grown hadrosaur or ceratopsian approaching water during drought season may have represented both opportunity and risk. An adult dinosaur could potentially injure even a giant crocodilian if the attack failed. But young individuals, sick animals, exhausted migrants, or dinosaurs trapped in soft mud would have been far more vulnerable. That balance between caution and violence likely shaped the predator's behavior. One fascinating aspect of Deinosuchus is that it lived in ecosystems crowded with other major predators. Large tyrannosaurs roamed certain regions. Smaller theropods hunted through forests and floodplains. Giant pterosaurs moved overhead. Massive sharks dominated coastal waters nearby. This was not a world where one predator controlled every environment equally. Instead, power shifted depending on location. Open land favored fast-moving theropods. Deep marine environments belonged to giant sea reptiles and sharks. But shallow rivers, estuaries, and swamp edges may have belonged to Deinosuchus. That territorial separation matters because prehistoric ecosystems were likely more complex than simple apex predator rankings suggest. Nature rarely operates through one unbeatable animal dominating everything. Most predators survive by controlling particular circumstances better than competitors do, and few creatures were better adapted to hidden aquatic ambush than giant crocodilians. The climate itself may have contributed heavily to Deinosuchus reaching such enormous size. Warm temperatures across the Cretaceous world allowed reptiles to remain active longer during the year. Rich coastal ecosystems supported enormous prey populations. Vast wetlands created ideal ambush territory. Some researchers also believe fluctuating sea levels expanded shallow environments perfect for crocodilian lifestyles. The result was a continent filled with waterways functioning almost like predator highways. Rivers connected feeding zones across massive distances. Seasonal floods redistributed carcasses and prey populations. And giant crocodilians occupied the center of this network. Yet, despite their terrifying image, there are still mysteries surrounding how Deinosuchus actually behaved. Some paleontologists argue it may have spent significant time scavenging, rather than constantly hunting large dinosaurs. That interpretation is not weakness. Modern crocodiles are extraordinary scavengers because water naturally carries dead animals downstream. In flood-heavy ecosystems, giant carcasses may have become predictable food sources. A creature capable of crushing bone could exploit remains other predators struggled to process efficiently. And scavenging itself often blurs into predation in complex ecosystems. An injured dinosaur escaping one attack may later become vulnerable to another predator entirely. A carcass found in a river may have died from drought, disease, fighting, or ambush. Fossils rarely preserve the full sequence clearly enough to separate every possibility. That uncertainty keeps Deinosuchus suspended between scientific evidence and primal imagination. But some clues remain difficult to ignore. Its bite force almost certainly ranked among the strongest of any predator in its ecosystem. The structure of its skull indicates resistance against enormous stress loads, and unlike many predators built primarily for speed, crocodilians survive through mechanical advantage and energy conservation. They turn patience into lethality. One particularly unsettling possibility is that dinosaurs living near crocodilian territory may have developed behavioral adaptations around waterways, similar to modern herbivores crossing crocodile-infested rivers today. Herd movement, hesitation at shorelines, choosing safer crossing points, increased vigilance during droughts. None of this fossilizes easily, but predator pressure shapes behavior constantly in modern ecosystems. If Deinosuchus regularly targeted river crossings, entire dinosaur migration patterns may have been influenced by hidden aquatic threats. Imagine enormous herds gathering beside dark water, while younger individuals stay near the center of the group. The surface appears still, except for drifting vegetation and insects touching the water. Somewhere beneath that surface waits a predator that has perhaps not eaten in weeks, yet remains perfectly capable of explosive violence at any second. And unlike active hunters constantly searching for prey, Deinosuchus may have existed in long stretches of near total stillness. That stillness creates psychological terror because it removes warning. The attack begins almost at the exact moment visibility disappears. Toward the later years of the Cretaceous, these giant crocodilians continued surviving alongside some of the most iconic dinosaurs ever discovered. They endured because their strategy required remarkably little change. Water remained essential. Prey remained vulnerable near shorelines. Ambush remained effective. In a world obsessed with giant dinosaurs crashing across landscapes, Deinosuchus represents something colder and quieter. A predator that rarely needed to announce itself. A creature that may have spent hours submerged in muddy water, waiting for one mistake. And perhaps that is why giant crocodilians continue feeling uniquely disturbing even today. Dinosaurs often seem distant because no modern equivalent truly exists. But crocodilians survived. The shape still remains. The eyes above the waterline still remain. The sudden explosion of violence still remains. Deinosuchus was not a completely alien monster. It was something far more unsettling. A recognizable predator pushed to prehistoric extremes, hiding in rivers that dinosaurs themselves may have learned to fear. The terrifying thing about giant prehistoric crocodilians is that they probably did not hunt the way most people imagine large predators hunting. There was no long chase across open plains, no dramatic sprint through forests, no roaring pursuit visible from miles away. In many cases, the attack may have begun in complete silence before the victim even realized danger existed. That difference matters because ambush predators operate under entirely different rules than active hunters. A tyrannosaur succeeds through movement, intimidation, and overwhelming force delivered directly in front of its prey. But giant crocodilians transformed stillness itself into a weapon. And in the prehistoric world, where nearly every animal eventually needed water, that strategy may have made river systems some of the deadliest places on Earth. Modern crocodiles already provide unsettling clues about how these ancient attacks likely unfolded. Large crocodilians rarely waste energy unnecessarily. They study movement. They wait near predictable crossing points. They attack when gravity and panic weaken the target at the exact same moment. Some modern Nile crocodiles observe herds for days before striking. Others position themselves downstream, where exhausted animals naturally drift during crossings. This patience is not passive. It is calculated energy conservation shaped by millions of years of evolution. Now imagine scaling that behavior into a world containing crocodilians larger than cars, living beside dinosaurs weighing several tons. The mechanics of the attack become horrifyingly efficient. A dinosaur approaching water would immediately face several disadvantages. Muddy shorelines reduce traction. Wet sediment shifts beneath heavy weight. Visibility near rivers often becomes distorted by vegetation, fog, and murky water. Even massive herbivores could lose balance during steep descents toward riverbanks. And unlike land predators forced to overpower prey entirely through muscle, giant crocodilians only needed partial control long enough to drag the victim into water, where buoyancy changed everything. Water removes stability. Legs become less effective. Momentum disappears. Panic increases oxygen demand. Once a large animal loses footing in deep water, even immense size may no longer guarantee survival. That principle exists in modern ecosystems constantly. Adult wildebeest, weighing hundreds of pounds, can be dragged underwater by crocodiles far smaller than prehistoric giants. Zebras, capable of devastating kicks, still die in river ambushes because the environment itself assists the predator. Prehistoric crocodilians likely exploited the same weakness against dinosaurs. Some paleontologists believe juvenile dinosaurs would have been especially vulnerable. Young hadrosaurs moving near river edges may have represented ideal targets because they lacked the mass and experience of adults. But the fossil evidence suggests attacks may not have been limited to small prey. Bite marks attributed to giant crocodilians appear on bones from surprisingly large dinosaurs. In some cases, the damage indicates crushing force, powerful enough to fracture thick skeletal structures. Whether those attacks resulted in immediate kills remains uncertain, but they reveal something important about prehistoric crocodilian behavior. These predators were not avoiding large dinosaurs entirely. They were interacting with them directly. One possible hunting scenario may have involved targeting moments of transition rather than moments of strength. Dinosaurs crossing rivers during seasonal migration would likely bunch together in unstable terrain. Mud could trap feet temporarily. Water currents might separate younger individuals from the herd. Large herbivores entering deep channels may have needed to swim rather than walk. That transition between stable land and unstable water creates vulnerability even in modern animals. A crocodilian hidden beneath muddy water does not need to dominate the prey physically at first. It only needs one secure bite combined with momentum and surprise. Once balance disappears, the entire encounter changes. Another disturbing detail is that giant crocodilians may not have killed immediately. Modern crocodiles frequently drown prey by pulling them underwater repeatedly until exhaustion takes over. Some perform the infamous death roll, spinning violently to tear flesh and destabilize struggling animals. Whether gigantic prehistoric crocodilians used identical techniques remains debated because body proportions varied between species. But the general strategy of overwhelming prey through water control likely remains similar. Imagine a hadrosaur partially submerged in a river, while several tons of muscle suddenly twist beneath the surface. Visibility vanishes. Water churns into mud and blood. Herd members panic along the shoreline, but cannot reach the attack clearly enough to intervene. Within seconds, the environment itself becomes part of the predator's body. One fascinating possibility is that some prehistoric crocodilians learned seasonal behavior patterns in dinosaur populations, much like modern predators anticipate migrations today. River crossings are predictable because geography forces repetition. Herds often return to similar water access points repeatedly. Predators exploiting those locations gain enormous advantages. Some researchers suspect ancient river systems may have functioned as recurring ambush zones, where giant crocodilians waited during periods of heavy dinosaur movement. This would help explain why ambush predation remained viable even against prey much larger than the predator's normal targets. The attack depended less on prolonged combat and more on timing. But there is still intense debate over how often giant crocodilians actively hunted fully grown dinosaurs. Some scientists argue that many bite-marked fossils may represent scavenging rather than predation. A dead dinosaur floating downstream would provide enormous food value for a giant crocodilian capable of crushing bone and tearing flesh efficiently. In ecosystems with frequent floods, droughts, disease, and predator conflicts, carcasses may have been relatively common along waterways. That interpretation would mean giant crocodilians functioned partly as cleanup predators, exploiting rivers as natural delivery systems for food. Yet, the distinction between scavenger and hunter may not have been as clear as people imagine. Modern crocodiles frequently switch between both roles depending on opportunity. An injured animal weakened near water can become prey, even if another predator caused the original damage. A carcass drifting downstream might attract multiple crocodilians competing violently over remains. Prehistoric river ecosystems were likely full of these blurred interactions, where death rarely belonged to a single hunter alone. Some paleontologists have proposed that giant crocodilians may have specialized more heavily on ambushing dinosaurs during drought periods, when water sources shrank dramatically. This idea makes ecological sense because concentrated water holes force prey into predictable locations. Modern African ecosystems demonstrate the same pattern constantly. During dry seasons, herbivores lose the luxury of avoiding dangerous rivers because thirst overrides caution. In the Cretaceous world, prolonged droughts could have transformed isolated waterways into deadly feeding zones where giant crocodilians gained enormous hunting advantages. And because crocodilians conserve energy so efficiently, they could potentially outlast many prey species during environmental stress. This patience may have been their greatest weapon. Dinosaurs often symbolize movement and dominance, but giant crocodilians mastered immobility. They turned waiting into survival strategy. Another reason prehistoric crocodilian attacks feel uniquely terrifying is because they likely violated the normal visual logic prey animals depended on. Most predators announce themselves through sound, movement, or scent before attacking. Crocodilians minimize all three. The water surface hides scale. Mud masks approach. The attack often begins beneath the prey's field of vision entirely. A dinosaur could approach a riverbank repeatedly without ever seeing the predator responsible for earlier disappearances. That hidden nature may have created constant tension around waterways in prehistoric ecosystems. Even large carnivorous dinosaurs might have behaved cautiously near deep channels, because ambush predators erase many advantages land hunters normally possess. There is also evidence suggesting some giant crocodilians could survive astonishing injuries, which may have made them even more dangerous over time. Modern crocodiles heal from wounds that would kill many mammals. Missing limbs, shattered jaws, and deep scars are surprisingly common among older individuals. If prehistoric species shared similar resilience, ancient rivers may have contained massive scarred predators carrying evidence of countless territorial fights and failed attacks. The oldest individuals may have become particularly formidable, not because they were constantly successful hunters, but because survival itself refined their strategy over decades. A giant crocodilian that lived long enough would not need reckless behavior. Experience alone would favor patience. Toward sunset in those ancient swamps, entire landscapes may have changed psychologically. Daytime heat faded into heavy, humid darkness. Insects filled the air. Herds gathered uneasily near shorelines. Water reflected fading orange skies while remaining completely unreadable beneath the surface. Somewhere under that water rested predators capable of exploding upward with impossible violence after hours of absolute stillness. And perhaps the most chilling part is that this hunting strategy never truly disappeared from Earth. The modern descendants of these ancient crocodilians still use nearly identical methods today. Millions of years passed, dinosaurs vanished, continents shifted, entire ecosystems collapsed. Yet, the basic formula survived almost unchanged because it worked so well from the beginning. Wait near water, conserve energy, strike during weakness. Drag the prey into an environment where panic becomes as deadly as teeth. Giant prehistoric crocodilians may not have hunted dinosaurs constantly, and they may not have dominated every ecosystem they entered, but in certain rivers, under the right conditions, they likely became something even more frightening than an active hunter. They became invisible danger woven directly into the landscape itself, turning the simple act of drinking water into one of the greatest risks in the prehistoric world. Few prehistoric matchups capture the imagination more than the idea of a giant crocodilian facing Tyrannosaurus rex. On the surface, it sounds almost inevitable, like two monsters from the same nightmare eventually colliding somewhere along a muddy riverbank. One ruled the land with crushing jaws and massive stride power. The other waited beneath dark water with armor-plated skin and explosive ambush force. People naturally want a winner because modern culture tends to reduce prehistoric life into battles, rankings, and dominance charts. But the deeper scientists study ancient ecosystems, the more complicated the question becomes. Because nature rarely rewards the strongest animal in every situation. It rewards the animal best adapted to a specific moment. And between a giant crocodilian and a T-Rex, the environment may have mattered more than raw power alone. The first thing to understand is that Tyrannosaurus rex and Deinosuchus never actually lived together. Their timelines missed each other by several million years. Deinosuchus disappeared before T-Rex rose to dominance in Western North America. That means no fossil evidence exists showing direct encounters between them. Still, comparing the two remains fascinating because they represent opposite solutions to becoming apex predators. Tyrannosaurus evolved into one of the most efficient terrestrial hunters the planet has ever produced. Deinosuchus and other giant crocodilians evolved into ambush specialists, capable of transforming water itself into a weapon. The contrast reveals something important about prehistoric ecosystems. Dominance was never universal. It shifted depending on terrain, visibility, and even gravity itself. On open ground, a fully grown T-Rex would almost certainly have held the advantage. Its body was built for movement across land despite its immense weight. Powerful hind limbs allowed it to cover territory efficiently. Its vision was likely exceptional, with forward-facing eyes providing strong depth perception. Its skull was engineered for devastating bite force, combined with bone-crushing teeth capable of splintering massive prey. Some studies estimate T-Rex bite force exceeded almost any land predator in history. And unlike crocodilians, which rely heavily on sudden ambush, Tyrannosaurus may have been capable of sustained pursuit over moderate distances. Even today, there are few living predators comparable to a fully grown T-Rex, standing over 12 feet tall at the hips, with jaws large enough to crush through thick bone effortlessly. But prehistoric crocodilians were dangerous, precisely because they rarely fought on equal terms. A giant crocodilian confronting T-Rex directly on dry land would likely face severe disadvantages. Its body plan favored low positioning and aquatic movement, rather than upright terrestrial mobility. Turning speed would suffer on firm ground. Endurance would remain limited. The crocodilian's best chance would involve defending itself with bite force and armor, while attempting to drag the encounter toward water. And that is where the balance begins shifting dramatically. Water changes physics in ways that become extremely important for large predators. A creature as massive as T-Rex depended heavily on stable footing. Its size generated enormous force through momentum and balance. But in deep mud or water, that stability becomes uncertain. Every step risks slipping. Turning becomes slower. Weight distribution changes unpredictably. A giant crocodilian adapted perfectly for semi-aquatic environments could exploit those weaknesses immediately. Modern crocodiles already demonstrate how quickly large prey lose control once dragged partially underwater. Even strong animals panic when balance disappears. And panic itself becomes deadly because oxygen demand rises while movement becomes less coordinated. Imagine a giant theropod attempting to pull free while several tons of muscle twist beneath the surface. The battle would not resemble cinematic dinosaur fights with prolonged, roaring clashes. It would likely become chaotic and brutally short. One powerful bite in the correct location might decide everything within seconds. Some paleontologists have suggested that large theropods may have avoided unnecessary conflicts with giant crocodilians whenever possible. This idea fits modern predator behavior surprisingly well. Large predators today often avoid fights that risk serious injury because even victorious encounters can become fatal later through infection or impaired mobility. A lion can technically kill a crocodile under certain conditions, but most avoid direct confrontations near water because the risk is enormous. The same logic may have applied in prehistoric ecosystems. A T-Rex might dominate most land-based confrontations, yet still behave cautiously around deep rivers occupied by giant crocodilians. In that sense, stronger becomes a misleading word. Ecological control matters more than universal superiority. Some scientists even argue that crocodilians represent one of evolution's most successful body plans precisely because they avoid unnecessary energy expenditure. Tyrannosaurs were active hunters, requiring constant food intake to support massive bodies and movement. Giant crocodilians, by contrast, could survive long periods with remarkably little food thanks to slower metabolisms and efficient ambush strategies. That difference may sound less dramatic than bite force comparisons, but over millions of years, energy efficiency becomes one of the most powerful survival advantages imaginable. Crocodilians survived asteroid impacts, climate collapse, and mass extinctions, while most giant terrestrial predators vanished completely. There is something deeply unsettling about that fact. The quieter strategy endured longer. Another fascinating detail emerges when examining how differently these predators perceived territory. A T-Rex likely experienced the world through movement across vast hunting ranges. It scanned landscapes visually, followed prey trails, and actively interacted with open environments. Giant crocodilians experienced territory differently. Rivers, estuaries, swamps, and shorelines formed ambush corridors where patience replaced pursuit. Their battlefield was narrower, but far more deceptive. One of the reasons humans instinctively fear crocodilians, even today, is because they weaponize uncertainty. The surface reveals almost nothing. Danger exists beneath visibility itself. That hidden quality changes how power feels psychologically. A T-Rex inspires fear through size and obvious dominance. A giant crocodilian inspires fear through invisibility. The attack begins before the victim fully understands what is happening. Some hypothetical comparisons focus heavily on bite force numbers, but those measurements alone can become misleading. Tyrannosaurus possessed one of the strongest bites among terrestrial animals ever studied, capable of crushing bone with extraordinary pressure. Giant crocodilians also generated tremendous bite force, especially through ambush leverage in water. But actual combat effectiveness depends on far more than raw numbers. Positioning matters. Terrain matters. Timing matters. A predator attacking from concealment gains advantages no direct confrontation can replicate. This may explain why modern crocodilians continue killing animals far larger than themselves under the right conditions. They do not overpower prey through symmetrical combat. They manipulate environment and surprise. There is also the question of intelligence and behavioral flexibility. Tyrannosaurs may have possessed relatively advanced sensory processing compared to many reptiles. Their brains, while not mammalian, suggest strong visual coordination and active predatory behavior. Crocodilians, however, should not be underestimated cognitively. Modern crocodiles display surprisingly complex hunting tactics, including coordinated movement, environmental awareness, and even strategic patience during migration seasons. Intelligence in predators does not always appear as problem-solving in the mammalian sense. Sometimes it appears as extraordinary timing, refined through instinct and experience. A giant crocodilian surviving decades in dangerous prehistoric waterways may have become remarkably effective simply through repeated exposure to prey behavior. Toward dusk in the late Cretaceous world, the difference between these predators may have become almost symbolic of two competing evolutionary philosophies. One moved openly through forests and plains, dominating through physical presence. The other remained half-hidden in water, dominating through restraint. One relied on active confrontation, the other waited for mistakes. And strangely, both strategies worked incredibly well for millions of years. Perhaps the most realistic answer to the question of who was stronger is that neither animal truly needed to prove absolute dominance over the other. Nature does not build ecosystems around tournament brackets. It builds systems of overlapping territories where survival depends on avoiding unfavorable conditions whenever possible. A T-Rex near deep water may have been cautious for good reason. A giant crocodilian stranded too far onto land may have become vulnerable quickly. Both predators likely understood their environments far better than dramatic modern reconstructions sometimes suggest. Yet the fascination with the matchup never disappears, because it touches something deeper than simple curiosity about dinosaurs. It forces people to reconsider how power actually works in nature. The largest predator is not always safest everywhere. The loudest hunter is not always the deadliest. Sometimes, the most dangerous creature in an ecosystem is the one that waits silently beneath the surface while everything else assumes the shoreline is safe. In the age of dinosaurs, rivers were not peaceful places separating forests and plains. They were entire ecosystems of violence, hidden beneath dark water and drifting vegetation. Places where life gathered in enormous numbers because survival demanded it, and where death waited with equal patience. Nearly every prehistoric creature eventually approached water. Giant herbivores needed to drink constantly to sustain their massive bodies. Predators followed migrating herds toward river valleys. Fish crowded shallow channels during dry seasons. Carcasses drifted downstream after storms and floods. And because so much life concentrated around these waterways, the rivers themselves became some of the most dangerous environments on Earth. Modern nature still offers glimpses of this ancient reality. In parts of Africa today, river crossings become moments of pure chaos, as crocodiles explode from muddy water while hundreds of animals panic simultaneously. But compared to the rivers of the late Cretaceous, modern ecosystems may seem almost restrained. Ancient waterways contained predators operating at scales difficult to imagine now. Giant crocodilians were only part of the danger. Some rivers held fish larger than sharks. Massive turtles moved slowly through submerged forests. Predatory fish with jaws filled with blade-like teeth hunted beneath the surface. Entire ecosystems existed in water thick with sediment, where visibility vanished almost immediately below the surface. To enter these rivers was to step into territory controlled by creatures evolution had specifically designed for concealment. One reason prehistoric rivers became so deadly is that the climate itself amplified instability constantly. The Cretaceous world was warmer and more humid across many regions than modern Earth. Storm systems could become enormous. Floodplains expanded for miles during heavy rainfall, then shrank dramatically during drought periods. Rivers changed shape seasonally, carving new channels while abandoning older ones. Entire forests sometimes drowned beneath floodwaters. Mud trapped enormous animals unexpectedly. Carcasses collected in stagnant pools as water levels dropped. These conditions created perfect opportunities for ambush predators and scavengers alike. In stable environments, prey animals can often predict danger patterns, but constantly shifting wetlands create uncertainty, and uncertainty favors predators capable of adapting quickly. Giant crocodilians thrived in exactly those conditions because they did not depend on stable hunting grounds. they depended on vulnerable moments. During flood seasons, rivers became highways, carrying food directly toward predators. Dead animals swept downstream after storms. Exhausted dinosaurs crossing flooded channels struggled against powerful currents. Juveniles separated from herds easily in deep water. Even powerful predators risked injury if trapped in unstable mud near riverbanks. One fascinating possibility is that giant crocodilians may have timed parts of their behavior around these environmental cycles. Modern crocodiles already respond strongly to seasonal changes, positioning themselves strategically during migrations or droughts. Prehistoric species likely did the same on an even larger scale. A shrinking river during drought season could become an enormous feeding zone as thirsty animals gathered around the last reliable water source. Imagine dozens of dinosaurs crowding muddy shorelines while hidden predators waited motionless beneath the surface. The environment itself would create panic before any attack even began. Another unsettling detail about prehistoric rivers is how visibility worked against large land animals constantly. Dinosaurs dominated open terrain because many relied heavily on sight, speed, and physical intimidation. But rivers erase those advantages quickly. Water reflects sunlight unpredictably. Sediment clouds movement. Dense reeds limit visibility along shorelines. A giant herbivore might detect a theropod approaching across open ground from hundreds of feet away, yet fail to notice a massive crocodilian lying almost completely submerged, only yards from the bank. This hidden danger likely transformed waterways into psychologically stressful environments, even when no attack occurred. Modern animals already behave differently near crocodile-infested rivers. They hesitate. They bunch together. They scan the surface constantly. It is difficult to imagine dinosaurs behaving entirely differently after millions of years evolving beside giant aquatic predators. Some paleontologists suspect entire migration routes may have formed partly around avoiding particularly dangerous waterways. Fossils from ancient river systems often reveal extraordinary concentrations of life and death layered together in chaotic patterns. Bones from multiple species appear mixed within flood sediments. Teeth from predators scatter through mudstone deposits alongside fish remains and plant material. These sites tell stories of ecosystems constantly rearranged by water itself. A dinosaur killed miles upstream might eventually become food for scavengers far away, after flooding carried the carcass downstream. Giant crocodilians likely exploited this system efficiently. They did not necessarily need to hunt constantly when rivers themselves delivered opportunities repeatedly. This raises one of the more debated ideas surrounding prehistoric crocodilians. Some researchers argue their reputation as dinosaur killers may partly come from scavenging behavior amplified by the fossil record. A giant crocodilian feeding on dinosaur carcasses regularly would still leave bite marks on bones, identical to those from active attacks. Waterways naturally accumulate dead animals for many reasons unrelated to predation: disease, drought, starvation, injury, territorial conflict, or flooding. In ecosystems this unstable, scavenging may have been incredibly important, even for giant predators. But that does not make these rivers less terrifying. In fact, it may make them more realistic. Death in prehistoric ecosystems was likely far messier and less dramatic than cinematic predator battles suggest. Rivers did not separate hunters from scavengers cleanly. They blended every role together into one continuous cycle where anything weak, trapped, or dead became part of the ecosystem almost immediately. The deeper scientists study modern crocodilians, the easier it becomes to imagine how prehistoric river systems operated. Crocodiles today are astonishingly adaptable predators. They can remain still for hours while monitoring movement near shorelines. They understand migration timing. They exploit herd behavior. Some even use environmental cover strategically while approaching prey. Scaling those instincts into giant prehistoric species creates an image of rivers functioning almost like living traps. Water concealed enormous predators while simultaneously forcing prey animals toward predictable access points. The shoreline itself became dangerous terrain. And unlike predators dependent on constant pursuit, crocodilians conserved energy with extraordinary efficiency. They could afford patience in ecosystems where prey eventually had to approach water, no matter how dangerous it seemed. One particularly haunting possibility is that ancient rivers may have sounded deceptively calm much of the time. Modern predator scenes often focus on constant action, but real ambush ecosystems are dominated by stillness, interrupted by sudden violence. The Cretaceous floodplains may have been filled with long stretches of humid silence, broken only by insects, distant movement, and water against mudbanks. Then suddenly, everything exploded. Birds or pterosaurs scattering overhead, herds stampeding backward from shorelines, water erupting into foam and mud, and seconds later, silence returning almost immediately while the river swallowed the evidence. That hidden rhythm of prehistoric rivers may explain why giant crocodilians feel uniquely disturbing compared to many dinosaurs. They transformed ordinary environmental features into threats. A forest announces concealment openly. A river appears calm until the exact moment it becomes lethal. Some waterways likely became especially infamous within local ecosystems simply because geography concentrated danger there repeatedly. Narrow crossings, deep channels beside steep banks, mud-heavy shorelines, where heavy animals lost footing easily. Predators learn these patterns quickly in modern ecosystems, and prehistoric crocodilians almost certainly did the same. An enormous Deinosuchus positioned at a major crossing point may have represented a constant threat influencing movement patterns across entire regions. Large herbivores may have approached certain rivers reluctantly during droughts, forced by thirst into dangerous territory they otherwise avoided. The river itself became an ecological pressure shaping behavior. Yet, despite all this danger, rivers also created life on extraordinary scales. The same floodplains that killed animals also supported enormous biodiversity. Vegetation flourished in nutrient-rich sediment. Fish populations exploded in warm, shallow waters. Young dinosaurs may have depended on wetlands for food and protection. Predators gathered because prey gathered first. In many ways, Prehistoric rivers resembled giant arteries carrying energy through entire ecosystems. They sustained life while simultaneously concentrating death. That balance appears repeatedly throughout natural history. The environments most essential for survival often become the most dangerous, because every creature is drawn toward them eventually. Toward evening in those ancient wetlands, the atmosphere may have felt almost dreamlike. Warm fog drifting above dark water, insects hovering over reeds taller than a person, massive silhouettes moving slowly through distant mist. The surface of the river nearly motionless, except for ripples from unseen movement beneath. Somewhere underwater rested predators large enough to drag dinosaurs into darkness. Nearby, scavengers waited for remains. Fish circled below drifting carcasses after floods. And overhead, storms built once again across prehistoric skies that had watched this cycle repeat for millions of years. The rivers of the dinosaur age were not simply backgrounds for prehistoric life. They were active forces shaping evolution itself, feeding giants while quietly consuming them at the same time. One of the strangest things about trying to understand the prehistoric world is realizing that almost everything scientists know comes from fragments that were never meant to survive. A single tooth buried in mud for 80 million years. A cracked vertebra exposed after a flood erodes a riverbank. A deep puncture mark, frozen inside fossilized bone. Entire theories about giant predators can rise or collapse because of details smaller than a human hand. And when it comes to giant prehistoric crocodilians, some of the most important evidence ever discovered is also some of the most disputed. Because the deeper paleontologists look at certain fossils, the harder it becomes to answer one unsettling question clearly. Were these ancient crocodilians truly hunting dinosaurs regularly? Or are scientists accidentally building dramatic stories out of incomplete moments preserved by chance? The debate begins with bite marks. At first glance, they seem straightforward. Fossilized dinosaur bones from parts of North America contain enormous punctures, gouges, and crushing damage matching the teeth of giant crocodilians like Deinosuchus. Some marks appear along limb bones, others near tails or hips. In a few cases, the spacing between punctures fits surprisingly well with reconstructed crocodilian jaws. To many people, that sounds like direct proof of prehistoric ambush attacks. A giant crocodilian bites a dinosaur. The dinosaur dies. Mystery solved. But fossil evidence almost never works that cleanly. The problem is that bones preserve outcomes, not full stories. A bite mark proves contact happened. It does not automatically reveal whether the victim was alive, dying, trapped, or already dead when the bite occurred. That distinction changes everything. Modern crocodiles scavenge constantly. They consume carcasses drifting through rivers. They tear apart dead animals trapped in mud. They steal kills from other predators whenever possible. A crocodilian feeding on an already dead dinosaur would leave marks almost identical to those from an active attack. And because prehistoric river systems naturally collected carcasses through floods and currents, giant crocodilians may have encountered dead dinosaurs regularly without needing to hunt them directly every time. Yet some fossils complicate the scavenging explanation in fascinating ways. A few dinosaur bones bearing crocodilian bite marks also show signs of healing. That detail is critical. Bone only heals if the animal survives after the injury. Somewhere in the late Cretaceous world, giant crocodilians attacked living dinosaurs hard enough to damage their skeletons permanently, and at least some victims escaped long enough for healing tissue to form. These fossils transformed the conversation completely because they demonstrated active encounters rather than simple scavenging. But even then, uncertainty remained. Did the crocodilian intend to kill? Was the dinosaur dragged partially into water before escaping? Did the predator target juveniles more often than adults? Fossils answer some questions while creating new ones immediately afterward. One particularly debated specimen involved hadrosaur bones carrying large bite impressions, believed to match Deinosuchus teeth. Some researchers interpreted the marks as evidence of ambush predation near water. Others argued the crocodilian may simply have scavenged the carcass after death. The frustrating part is that both explanations remain plausible. This is one reason paleontology often feels less like solving puzzles and more like reconstructing shadows. Scientists are not observing prehistoric behavior directly. They are interpreting damage patterns left behind by ecosystems destroyed tens of millions of years ago. Water erases evidence aggressively. Floods scatter remains. Predators disturb carcasses. Sediment crushes bones under immense pressure over geological time. What survives is incomplete by definition. And yet sometimes the fragments become disturbingly vivid. In certain fossils, the bite pressure itself appears extraordinary. Bones show crushing damage consistent with immense force rather than light scavenging behavior. Some punctures penetrate thick skeletal areas, requiring tremendous jaw strength. That supports the idea that giant crocodilians were fully capable of attacking large prey directly if conditions favored them. But capability does not necessarily reveal frequency. A modern crocodile can kill a buffalo under ideal circumstances, yet that does not mean buffalo make up most of its diet. Predators often survive through opportunism rather than constant dramatic kills. This tension between what was possible and what was common sits at the center of nearly every debate surrounding prehistoric crocodilians. Another complication comes from how fossil sites form in the first place. Many famous dinosaur bone beds accumulated near ancient waterways because rivers preserve sediment exceptionally well. That means scientists naturally discover more fossils connected to aquatic environments than some other habitats. As a result, giant crocodilian interactions may appear disproportionately common simply because river systems preserved evidence more effectively. In other words, prehistoric rivers might dominate the fossil record partly because they were excellent burial environments, not necessarily because every dinosaur constantly died there. This possibility forces paleontologists to remain cautious when interpreting predator behavior from incomplete ecosystems. But caution itself creates fascinating scientific tension. Popular media often presents prehistoric life with absolute certainty. Giant crocodilian attacks are shown in dramatic cinematic detail as though cameras recorded them directly. Real science operates differently. Researchers debate tooth spacing. They compare fracture patterns. They analyze microscopic damage around wounds. Sometimes, a single fossil shifts interpretations completely. Other times, scientists spend decades arguing over the meaning of one damaged bone because no new evidence appears to resolve the disagreement fully. And, strangely, that uncertainty may make prehistoric ecosystems feel more real rather than less. Nature is rarely simple enough to fit clean narratives. One especially intriguing idea proposed by some researchers is that giant crocodilians may have behaved differently depending on environmental conditions. During wet seasons with abundant fish and aquatic prey, they may have relied less on dangerous attacks against large dinosaurs. During droughts, however, shrinking water sources could force more direct predator-prey encounters near crowded riverbanks. This seasonal interpretation would explain why evidence appears inconsistent across fossil sites. Some regions may preserve signs of active predation, while others mainly show scavenging behavior. Ecosystems change constantly. Predators adapt accordingly. Another layer of mystery involves the crocodilians themselves. Most giant prehistoric crocodilians are known from incomplete remains. Scientists reconstruct their size and behavior using skull fragments, teeth, vertebrae, and armored plates scattered across different locations. That means even the appearance of these animals remains partly interpretive. Some reconstructions portray them as heavily aquatic ambush predators, rarely leaving water. Others suggest they moved across land more actively than expected. Body proportions change hunting possibilities dramatically. A crocodilian spending more time on land might interact with dinosaurs differently than one remaining almost entirely aquatic. Again, the fossil record refuses to provide perfectly clean answers. There are also fossils suggesting interactions between giant crocodilians and other predators. Bite marks appear on bones already damaged by theropod dinosaurs. Some carcasses show evidence of multiple scavengers feeding at different times. These discoveries reveal prehistoric rivers as chaotic ecological systems rather than isolated predator-prey scenes. A dead dinosaur near water may attract crocodilians, smaller predators, fish, insects, and scavengers simultaneously. By the time fossilization begins, the original sequence of events may already be almost impossible to reconstruct precisely. This complexity matters because it changes how prehistoric ecosystems feel emotionally. Instead of simple cinematic battles between clear heroes and villains, the fossil evidence suggests messy, overlapping worlds where survival depended heavily on timing, injury, environment, and chance. One storm could drown herds. One drought could trap predators together around shrinking water holes. One infected wound could kill even enormous animals slowly over weeks. Giant crocodilians existed inside that instability rather than above it. Toward the end of many excavations, paleontologists often experience something strangely humbling. After years of analysis, scanning, comparison, and debate, the final answer sometimes remains uncertain. A fossil may strongly suggest predation, without proving it completely. A bite mark may indicate scavenging while still leaving room for active hunting. Some researchers become more cautious over time rather than more confident, because the deeper they study prehistoric ecosystems, the clearer it becomes how many details disappeared forever long before humans arrived. Yet those missing details are exactly what keep the mystery alive. A healed bite mark on a dinosaur bone hints at an attack that happened beside a river under skies no human ever saw. Crushed vertebrae suggest immense force exploding from muddy water. Tooth punctures reveal moments of contact between predators and prey, separated from us by almost unimaginable stretches of time. And hidden inside those fragments is a larger truth about paleontology itself. The prehistoric world is not fully gone. Pieces of it still exist beneath deserts, cliffs, riverbanks, and badlands, waiting to be uncovered. Each fossil acts like a brief flicker of light into ecosystems otherwise swallowed by deep time. Sometimes that light reveals clear answers. Other times, it only deepens the mystery, forcing scientists to confront how much of Earth's ancient history still remains hidden beneath stone and silence. There is something strangely unsettling about looking into the eyes of a modern crocodile and realizing that creatures with nearly the same silhouette watched dinosaurs walk along riverbanks tens of millions of years ago. Entire worlds disappeared. Mountains rose and eroded away. Oceans opened and closed. The asteroid impact at the end of the Cretaceous erased most giant reptiles from Earth forever. Yet, crocodilians survived, carrying forward a body plan so ancient that parts of it would still look familiar to predators living before Tyrannosaurus rex even existed. People often call crocodiles living fossils, but that phrase can accidentally create the wrong impression, as though evolution simply forgot about them while everything else changed. In reality, crocodilians did evolve over time. Ancient species varied dramatically in size, habitat, skull shape, and behavior. Some prehistoric crocodilians became fully marine hunters. Others evolved hoof-like limbs for movement on land. Some resembled giant wolves more than modern alligators. But despite this diversity, the core crocodilian formula remained remarkably stable across immense stretches of geological time. And that raises one of the most fascinating questions in evolution. Why would a lineage survive for over 200 million years with its basic design still recognizable, while so many other dominant predators vanished completely? Part of the answer may be uncomfortable, because it challenges how humans usually think about progress in nature. People often assume evolution always pushes animals toward becoming faster, smarter, more advanced, or more specialized. But evolution does not work toward perfection. It works toward survival. If a body plan already functions extremely well across changing environments, dramatic redesign becomes unnecessary and sometimes even dangerous. Crocodilians may represent one of the clearest examples of this principle ever discovered. Their anatomy solved several ecological problems so efficiently that natural selection kept preserving the same core strategy again and again. The first key to their survival is energy efficiency. Large mammals and active predators burn enormous amounts of calories simply staying alive. They need constant food to support warm-blooded metabolisms and sustained movement. Crocodilians operate differently. As ectothermic reptiles, they rely heavily on external temperatures to regulate body heat, allowing them to survive on far less food than similarly sized mammals or many dinosaurs likely required. A large crocodile can go weeks or even months between major meals under the right conditions. That ability becomes incredibly important during environmental collapse. When ecosystems destabilize and prey becomes scarce, animals with lower energy demands often survive longer. Some researchers suspect this efficiency played a major role in helping crocodilian ancestors endure the catastrophic aftermath of the asteroid impact that killed non-avian dinosaurs around 66 million years ago. While massive predators dependent on huge prey populations disappeared, crocodilians may have persisted by slowing down, scavenging opportunistically, and surviving on reduced food sources for extended periods. Water itself may have helped them survive too. Aquatic and semi-aquatic environments can buffer temperature extremes more effectively than open land. Rivers, swamps, and estuaries often preserve pockets of life even during ecological disasters, because water stabilizes conditions and supports multiple food chains simultaneously. Crocodilians already occupied these environments naturally. They were not forced to reinvent their lifestyles after mass extinction events, because they already lived in ecosystems capable of sustaining fragmented survival networks. But survival alone does not explain why their physical appearance remained so effective for so long. To understand that, it helps to look closely at how perfectly crocodilian bodies function as ambush systems. Nearly every part of their anatomy supports the same strategy. Their eyes and nostrils sit high on the skull, allowing them to remain mostly submerged while monitoring surroundings. Their tails generate explosive acceleration in water. Their armored skin provides defense without sacrificing aquatic stability. Their jaws close with extraordinary force, while requiring relatively little movement to strike. Even their low profile reduces visibility near shorelines. Nothing about the design wastes energy unnecessarily. Modern engineers sometimes describe elegant machines as systems where removing any major component weakens overall performance. Crocodilians evolved into biological versions of that principle. They are terrifying, partly because they appear mechanically inevitable, as though millions of years of evolution gradually stripped away anything inefficient. Another reason crocodilians endured may involve behavioral flexibility. Despite their ancient appearance, they are not primitive in the simplistic sense people often imagine. Modern crocodilians display surprisingly complex behaviors. They learn migration patterns. They guard nests aggressively. Some species cooperate loosely during feeding situations. Others use environmental cover strategically while hunting. There are even documented cases of crocodiles balancing sticks on their snouts to attract nesting birds searching for materials. That combination of instinct and adaptability allows crocodilians to exploit changing ecosystems without requiring dramatic anatomical transformation. In evolutionary terms, flexibility often matters more than specialization during unstable periods of Earth's history. highly specialized predators can dominate temporarily, but they become vulnerable when environments shift rapidly. Crocodilians survived partly because they never depended entirely on one prey source or habitat type. They could scavenge, ambush, retreat into water, slow metabolism, or exploit multiple food chains depending on conditions. And perhaps most importantly, they mastered patience better than almost any large predator lineage in Earth's history. There is also something philosophically strange about the way crocodilians evolved compared to many famous prehistoric animals. Dinosaurs often inspire awe through extremes: enormous size, giant horns, armored tails, impossible neck lengths, massive claws. Crocodilians evolved toward restraint instead. They did not need towering legs or elaborate weapons because their environment already supplied advantages. Water concealed them. Mud slowed prey. Shorelines concentrated vulnerable animals naturally. Instead of becoming visually extravagant, crocodilians became increasingly efficient at disappearing. In many ways, they evolved around minimizing effort while maximizing timing. And that strategy may have proven more durable across deep time than raw physical dominance alone. Fossil evidence suggests crocodilian relatives survived multiple mass extinction events long before the dinosaurs disappeared. Their lineage stretches back to the Triassic period, meaning crocodilian ancestors witnessed ecosystems so ancient they existed before the first true dinosaurs fully dominated the planet. During that immense timeline, continents rearranged repeatedly, oxygen levels fluctuated, sea levels rose and fell dramatically. Entire predator groups emerged and vanished. Yet crocodilian forms kept reappearing because the ecological role itself remained valuable. Ambush predators near water solve recurring evolutionary problems efficiently. Prey always needs water eventually. Rivers naturally funnel movement. Aquatic concealment remains effective regardless of which species dominate the surrounding landscape. That consistency gave crocodilians extraordinary staying power. Some scientists argue that crocodilians also benefited from evolving into ecological middle ground, rather than pushing toward unstable extremes. They became large enough to dominate many environments, but not so massive that survival depended entirely on giant prey populations. They remained dangerous without requiring constant activity. They occupied aquatic territory without becoming fully dependent on open oceans, like some marine reptiles that vanished completely. In evolutionary history, balance often outlasts specialization. Another haunting detail is that modern crocodilians still trigger fear responses remarkably similar to what prehistoric animals may have experienced millions of years ago. Large mammals instinctively hesitate near crocodile-infested water. Birds alarm call at subtle movement along riverbanks. Entire herds alter crossing behavior because of hidden aquatic predators. These reactions exist because crocodilians exploit one of the oldest vulnerabilities in vertebrate survival: the uncertainty of water. On land, danger often announces itself visually. In water, visibility collapses. That primal fear likely existed long before humans evolved. Dinosaurs themselves may have developed behavioral caution around crocodilian habitats through repeated predation pressure across generations. In a sense, crocodilians survived not merely as predators, but as environmental forces shaping behavior itself. Toward evening in modern wetlands, it is still possible to glimpse echoes of worlds older than humanity can easily comprehend. A crocodile drifting almost motionless through dark water beneath orange light. Insects hovering over reeds. Silence interrupted suddenly by explosive movement before calm returns almost instantly. The scene feels ancient because it truly is ancient. The strategy worked before mammals dominated Earth. It worked before grasslands spread across continents. It worked before humans existed. And perhaps the most unsettling realization is that crocodilians survived not because evolution stopped changing them, but because evolution kept confirming that their fundamental design already worked extraordinarily well. While countless prehistoric giants vanished through overspecialization, competition, or environmental collapse, crocodilians endured by mastering efficiency, patience, and adaptability. They became proof that in nature, survival does not always belong to the fastest or most intelligent creature. Sometimes it belongs to the predator that wastes the least energy, waits the longest, and understands exactly when not to move at all. If Deinosuchus still existed today, the world would probably feel psychologically different long before it became physically different. People often imagine prehistoric predators returning as giant action movie monsters rampaging through cities. But the reality would likely be quieter and far more unsettling. The true impact of a surviving Deinosuchus would not begin with dramatic attacks. It would begin with fear, altering human behavior around water itself. Entire coastlines, river systems, and wetlands would suddenly feel ancient again, as though parts of modern civilization had been pushed backward into a much older relationship with nature. Because a crocodilian over 30 feet long does not simply become another dangerous animal, it changes how humans experience geography. Today, most people in developed countries walk near lakes, rivers, and marshes with relatively little fear. Children swim in freshwater reservoirs. Boats move casually through swamp channels. Waterfront homes are considered peaceful and desirable. But imagine knowing that somewhere beneath the surface of a slow-moving river might be an armored predator the size of a bus, capable of overturning small boats with explosive force. The shoreline itself would stop feeling safe. And perhaps the strangest part is that modern crocodiles already cause versions of this fear in certain regions today. Saltwater crocodiles still kill people in parts of Australia and Southeast Asia. Nile crocodiles remain among the deadliest large predators in Africa. Yet those animals are significantly smaller than Deinosuchus. Scaling that danger upward transforms entire ecosystems psychologically. Some rivers would become places humans avoid almost completely after dark. Fishing communities would change. Tourism would change. Cities built near wetlands might redesign infrastructure entirely around predator management. The most likely habitat for a modern Deinosuchus would probably include warm subtropical wetlands with massive prey availability and stable water systems. Places like the Gulf Coast of the United States, parts of the Amazon basin, northern Australia, or large African river systems might theoretically support such a predator under the right ecological conditions. But even then, major questions appear immediately. Could modern ecosystems actually feed an animal that enormous consistently? Giant crocodilians require immense calories over long lifespans, even with efficient reptilian metabolisms. Prehistoric river systems supported extraordinary biodiversity, partly because ancient climates and ecosystems functioned differently than modern industrialized environments. Rivers during the late Cretaceous flowed through vast, uninterrupted wetlands filled with giant reptiles, enormous fish, migrating dinosaur herds, and massive carrion events caused by floods and droughts. Modern ecosystems are fragmented heavily by human development, pollution, dams, agriculture, and overfishing. A surviving Deinosuchus would likely need either extremely protected territory or enormous ranges to sustain itself properly. That raises another fascinating possibility. Human civilization itself may prevent many giant prehistoric predators from surviving today, even if climate conditions remain suitable. Large predators struggle in modern environments because humans dominate landscapes so aggressively. Roads divide migration routes. Industrial fishing reduces prey populations. Wetlands disappear beneath cities and farmland. In some ways, the extinction of giant predators continues quietly even now. Animals that once controlled ecosystems lose territory gradually until only isolated populations remain. A modern Deinosuchus might survive for a time in remote wetlands, but eventually it would collide with human expansion almost everywhere. And that collision would likely become extremely complicated. One reason crocodilians survive so effectively today is that they are difficult to monitor even at smaller sizes. They remain submerged for long periods. They hide in dense vegetation. They move silently through water. A Deinosuchus would amplify those challenges dramatically. Imagine trying to track an animal weighing several tons through swamp systems stretching for hundreds of miles. Drones might miss it beneath tree cover. Boats entering certain waterways would constantly risk ambush. Even locating nesting sites could become dangerous. Some researchers speculate that ancient crocodilians may have lived surprisingly long lives, potentially several decades or more. If true, a surviving Deinosuchus population might develop behavioral familiarity with human activity over time, learning migration patterns, boat routes, fishing locations, and areas of predictable prey concentration, much like modern crocodiles already do on smaller scales. Another disturbing possibility is that modern humans are psychologically unprepared for predators operating through concealment rather than visibility. Most dangerous animals people fear today are either openly visible or technologically manageable. Sharks remain terrifying, partly because they share the same hidden quality crocodilians exploit. But Deinosuchus would combine aquatic invisibility with territorial dominance in freshwater environments humans use constantly. Rivers connect cities. Lakes support recreation. Wetlands attract tourism. A giant crocodilian occupying those spaces would force modern society into a more ancient mindset where approaching water always carries uncertainty. There is also the question of whether humans could realistically control such a predator. Technologically, the answer is probably yes, eventually. Modern firearms, drones, helicopters, and tracking systems give humans overwhelming advantages against large animals under many circumstances. But control does not necessarily mean easy coexistence. Elephants, bears, lions, and crocodiles already create major conservation conflicts today, despite being far smaller and more manageable than Deinosuchus. A giant crocodilian capable of attacking boats or livestock would generate enormous political pressure for removal or extermination quickly. Some communities might demand aggressive hunting programs. Others would argue for protected habitats. Scientists would rush to study the species, while local populations feared living nearby. The animal would become both a scientific miracle and a constant source of tension. Yet, there is another possibility people often overlook. Deinosuchus might avoid humans more than expected. Modern crocodilians generally do not hunt people constantly, despite their reputation. Most attacks occur because humans enter crocodile territory carelessly, approach nesting sites, or surprise animals at close range. A giant prehistoric crocodilian might behave similarly, preferring easier prey whenever possible. Large fish, livestock, deer, wild boar, or marine mammals could provide substantial food without risking direct confrontation with humans. In that scenario, the true horror would not come from frequent attacks, but from unpredictability. The knowledge that something enormous exists beneath dark water changes behavior even if encounters remain rare. In many ways, humans fear hidden apex predators more than visible ones, because uncertainty itself becomes exhausting. Every ripple feels suspicious. Every missing boat becomes a rumor. Every flooded riverbank after storms feels dangerous. And modern media would amplify that fear constantly. Satellite images, viral videos, grainy nighttime footage, stories from fishermen claiming they saw something massive moving beneath bridges. Entire internet cultures would form around tracking sightings and analyzing blurry recordings. Some people would become obsessed with proving the animals exist in certain rivers. Others would insist sightings were exaggerated hoaxes. The psychological atmosphere surrounding a modern Deinosuchus might resemble a strange combination of shark fear, cryptid mythology, and real predator ecology all at once. But perhaps the most fascinating consequence would involve perspective. Modern humanity often behaves as though large predators belong to the distant past or isolated wilderness far away from civilization. A surviving Deinosuchus would challenge that illusion immediately. It would remind people that for most of Earth's history, humans did not exist at the top of every ecosystem automatically. Our ancestors evolved in worlds where approaching water carried genuine mortal risk from hidden predators. In some regions of Africa and Asia, that ancient relationship still partially survives through crocodiles today. A giant prehistoric crocodilian would force technologically advanced societies to rediscover that vulnerability on a much larger scale. Towards sunset in a world containing Deinosuchus, some rivers would become eerily empty. Boats returning before dark. Fishermen watching shorelines carefully while fog gathered above black water. Warning signs near bridges and wetlands. News helicopters circling after unexplained disappearances. And somewhere beneath the surface, almost invisible except for drifting eyes above the waterline, a creature carrying instincts older than humanity itself, waiting with the same patience its ancestors used beside dinosaur-filled rivers tens of millions of years ago. That may be the most unsettling part of imagining Deinosuchus alive today. It would not feel like science fiction for very long. It would feel like a forgotten chapter of Earth's past, quietly reclaiming territory inside the modern world. When people imagine the prehistoric world, they usually picture dinosaurs first. Towering predators crossing open plains, herds of enormous herbivores moving beneath volcanic skies, giant claws, horns, teeth, and thunderous footsteps dominating landscapes that feel almost mythical now. For more than a century, dinosaurs became the symbols of absolute prehistoric power in human imagination. And in many ways, they truly were extraordinary. Some reached sizes no land animals have matched since. Others evolved intelligence, speed, armor, or weaponry so specialized that they transformed entire ecosystems around them. But the deeper scientists study prehistoric life, the more complicated the idea of ruling the ancient world becomes. Because the Earth of the dinosaurs was not controlled by one creature or one group alone. It was divided into invisible territories shaped by water, climate, geography, and fear. And hidden inside those divisions was a quieter kind of predator that survived far longer than almost all the giants surrounding it. The giant crocodilians force a different perspective on prehistory. They reveal that dominance in nature is rarely absolute. A Tyrannosaurus may have controlled open ground. Massive sauropods may have towered over forests. But rivers obeyed different laws entirely. Near shorelines, strength alone did not guarantee safety. Speed became less important. Size became less stable. Visibility disappeared. Water transformed the environment itself into part of the predator. And in those moments, giant crocodilians may have become among the most dangerous animals on Earth. What makes this realization so fascinating is that crocodilians achieved their success without evolving the dramatic features people usually associate with prehistoric dominance. Dinosaurs often became increasingly extreme over millions of years. Larger bodies, longer claws, more elaborate horns, more specialized hunting strategies. Giant crocodilians evolved toward efficiency instead. They mastered patience. They mastered concealment. They mastered energy conservation. And perhaps most importantly, they mastered waiting beside the one resource every large animal eventually needed. Water created a universal vulnerability no ecosystem could escape. Some paleontologists believe this may explain why crocodilian body plans survived repeated extinction events, while so many dominant terrestrial predators vanished completely. Crocodilians did not rely on controlling every environment. They controlled strategic environments that remained essential regardless of which species dominated nearby landscapes. Rivers always mattered. Wetlands always concentrated life. Floodplains always attracted prey. And hidden aquatic ambush remained effective across immense stretches of evolutionary time. That strategy may not appear as visually impressive as giant theropods charging across open ground, but survival over hundreds of millions of years suggests it was extraordinarily successful. One of the strangest truths about prehistoric ecosystems is that many animals probably spent much of their lives avoiding risks rather than seeking dominance. Modern nature works this way constantly. Lions avoid healthy elephants. Wolves hesitate around bears. Crocodiles retreat from hippos. Predators survive partly through understanding when not to fight. The prehistoric world likely operated under similar logic. A giant theropod approaching deep water may have recognized hidden danger instinctively. A crocodilian stranded too far onto land would lose many of its advantages quickly. Both predators occupied overlapping territories while respecting environmental boundaries shaped by experience and survival pressure. This changes the emotional atmosphere of the prehistoric world completely. Instead of imagining one supreme apex predator controlling everything, the Earth of the dinosaurs begins feeling more fragmented and unpredictable. Different ecosystems produced different rulers. Open plains favored one kind of hunter. Dense forests favored another. Rivers favored something colder and quieter. And because giant crocodilians rarely needed to announce themselves openly, their influence may have felt almost supernatural within those environments. A dinosaur could see a theropod approaching from a distance. But a hidden predator beneath muddy water transformed ordinary shorelines into uncertainty itself. Fossil evidence suggests giant crocodilians absolutely interacted with dinosaurs directly at times. Bite marks, healed injuries, and damaged bones reveal real encounters between enormous aquatic predators and terrestrial giants. Yet the evidence also refuses to support simplistic conclusions cleanly. Scientists still debate how often these crocodilians actively hunted large dinosaurs versus scavenging carcasses opportunistically. Some species may have specialized heavily on fish, while still attacking vulnerable dinosaurs occasionally. Others may have become more aggressive during droughts, when prey concentrated around shrinking water sources. The uncertainty matters because it reminds us that prehistoric ecosystems were likely more complex than dramatic cinematic battles suggest. Nature rarely organizes itself around clear winners and losers. It organizes around survival strategies, constantly shifting with climate, geography, and chance. There is also something almost philosophical about the contrast between dinosaurs and crocodilians. Dinosaurs often represented movement, expansion, and visible dominance. Giant crocodilians represented restraint, stillness, efficiency. They survived by minimizing wasted energy while maximizing timing. And in the end, when the asteroid impact reshaped Earth catastrophically 66 million years ago, the quieter strategy endured longer. Non-avian dinosaurs disappeared completely. Giant crocodilians vanished too, but the broader crocodilian lineage survived and continued evolving into the modern world. That survival carries a strange emotional weight, because it means part of the prehistoric world never truly ended. Modern crocodiles and alligators still use many of the same hunting methods their ancestors used beside dinosaur-filled rivers. They still wait beneath water, almost motionless. They still exploit moments of weakness near shorelines. They still weaponize invisibility and patience instead of constant movement. Millions of years passed, yet the core strategy remained terrifyingly effective. In some ways, crocodilians became living reminders that evolution does not necessarily reward the loudest or most dramatic creatures forever. Sometimes, it rewards the predators capable of enduring instability itself. Another fascinating possibility is that giant crocodilians influenced dinosaur evolution more than fossils can fully reveal. Predators shape ecosystems not only through direct kills, but through fear and behavior. Modern herbivores alter migration routes around dangerous rivers. Animals avoid certain watering holes. Herd structures change in response to predation pressure. If giant crocodilians occupied major waterways for millions of years, dinosaurs likely adapted behaviorally around those threats constantly. Entire prehistoric landscapes may have carried invisible maps of danger centered on rivers and wetlands. Fossils preserve bones more easily than behavior, so much of that ancient psychological world disappeared forever. But the possibility remains there, beneath the surface of every river system paleontologists uncover. Toward the end of the Cretaceous, enormous ecosystems stretched across the planet, beneath skies filled with volcanic haze, migrating pterosaurs, and endless wetland storms. Giant predators still moved across floodplains, while crocodilians drifted silently through dark water. Then, suddenly, in geological terms, almost instantly, much of that world vanished. Forests burned, food chains collapsed, oceans changed chemically, entire evolutionary dynasties ended permanently. Yet crocodilian descendants survived the catastrophe and continued waiting beside rivers long after the dinosaurs disappeared. That fact alone may be the closest thing nature offers to an answer about who truly ruled prehistory. Perhaps the most successful creatures were not necessarily the largest, fastest, or most visually terrifying. Perhaps they were the ones capable of surviving change itself. And maybe that is why giant crocodilians remain so haunting compared to many extinct predators. Dinosaurs can feel almost mythological now because nothing quite like them survived. But crocodilians still exist. Their eyes still rise above dark water, exactly as their ancestors' eyes once did beside ancient rivers filled with dinosaurs. Their attacks still happen with shocking suddenness after long silence. Their bodies still carry echoes of worlds older than humanity can easily comprehend. In the fading light of prehistoric wetlands, enormous dinosaurs may indeed have dominated the horizon. But beneath the water, hidden from view until the final second, another kind of ruler waited patiently in silence. Thanks for exploring the lost rivers of prehistoric Earth with me tonight. If you enjoyed this journey, don't forget to subscribe to Sleepy Earth channel for more relaxing prehistoric documentaries. And before you go, leave a comment telling me what mystery you'd like to explore next. Wherever you are tonight, I hope you have a peaceful evening, good luck, and a great night's sleep.